All right, page 10. Polynomials. Basically, we looked at how to solve polynomials. We looked at how to factor them, and by factoring them, we were able to solve them. We learned how to divide using synthetic and long division, and now we're going to review that. So, dividing a polynomial, which way would you guys like to start with? Long division or synthetic? Long? Okay. I'm going to do the long on this side because I have a bit more room over here. Okay, I have 4x cubed minus 13x plus 9. Which term is missing?
X squared.
The x squared, so we need a placeholder. Don't forget that. Okay, so we have 4x cubed plus 0x squared minus 13x plus 9. We're dividing by x plus 2. That's going to go on the outside. Just speaking about language, so far I have my polynomial underneath the division bar, and I have my divisor on the outside. Starting with x, I need to figure out what do I have to multiply by x to get 4x cubed? 4x squared. So above the 4x squared placeholder, the 0x squared placeholder, I'm going to put 4x squared. Then I need to multiply this 4x squared back by both terms in the divisor. So 4x squared times x gives me 4x cubed. And that's what we want. We want to have the exact same term as the first term. Okay, then we multiply 4x squared times 2, we get 8x squared. To simplify, our next step is to subtract. Okay, dad divides, mom multiplies, sister subtracts. Okay, 0 minus 8, we get negative 8x squared. Brother brings down negative 13x. Okay, dad, mom, sister, brother. I know it's silly and elementary, but hopefully it will help. Okay, what do I multiply by x to get negative x squared? 8x squared. Negative 8x. So multiply that back. Okay, mom's going to multiply negative 8x times x is negative 8x squared. Bit of a tongue twister. Okay, negative 8x times 2, negative 16x. We're going to subtract. So negative minus a negative is like adding. So we have negative 8 plus 8. These will cancel out. Negative 13 plus 16 is positive 3x. Be very careful with those negatives, positive negatives. They'll make all the difference. And then we bring down the 9. What do I multiply by x to get 3x? Positive 3. 3 times x is 3x, and 3 times 2 is 6. I'm going to subtract, 3x's cancel out, 9 minus 6 is 3. So, if I were to write this in the form polynomial equals divisor times quotient plus remainder, okay, I'm going to be a little bit lazy. I'm just going to write p for the original polynomial. Our divisor was x plus 2. Our quotient is on the top. Okay, that's 4x squared minus 8x plus 3. And our remainder is always at the bottom. We're going to add 3. Just a little review. What happens if that was a 0? What could I say about x plus 2? It divides evenly, so it's a factor. Good. Okay, that's long division. Let's review synthetic division. So, place your bar upside down. Okay, on the top level of the bar, we're going to put the coefficients of the polynomial. So we have 4x cubed, 0x squared, negative 13x, positive 9. The number that goes on the side is always the value of x if that was equal to 0, so we put negative 2. First we're going to bring down the 4, then we multiply by the divisor. So 4 times negative 2 is negative 8. One thing to remember is you add the rows. Okay, so 0 plus negative 8 is negative 8. Negative 8 times negative 2 is 16. Negative 13 plus 16, positive 3. 3 times negative 2 is negative 6. And 9 minus 6 is 3. Last digit is always what? Remainder. And this will be my quotient. Okay, starting at the constant, I have 3, negative 8x, and 4x squared. Does that look very similar to what we ended up with in the top there? Okay, the remainder was also the same. Personally, I like this method. It's super quick, fast, easy. The method, oh sorry. The only, I don't want to say that. If you were asked to say divide or factor a polynomial, if you only knew one, great. But sometimes they like to throw in questions like, oh, a student did long division and made a mistake. What step did they make a mistake in? So I think you should know both. Okay. Next up is the remainder and factor theorem. We kind of alluded to it already. If the remainder is 0, then the divisor was a factor. There's a quicker way to solve for that though. For example, if I went, I'm just going to go back to this question. If I went p of negative 2, and I subbed negative 2 into all of the x's here, 4, and then negative 2 cubed, minus 13 times negative 2, plus 9. Okay, if I got 0, then x minus 2 is a factor. But I'm going to end up with 3. So is x plus 2 a factor? No. But you thinking about the remainder theorem, p of negative 2 equals 3, if you're ever asked what's the remainder, rather than going through this whole process or this whole process, use the remainder theorem. Sub the divisor into the polynomial, got the remainder. Okay? That's just a little extension to what we're leading into. More complex question, which is more realistic of what you're going to see. Determine the value of k in the polynomial 8x cubed plus kx squared minus 11x minus 3 if p of 1 equals 0. So what does p of 1 equals 0 say?
That one's a factor. No.
What would be the factor in the binomial form?
X minus
1 is a factor. Okay. If you were looking at the graph, this is telling you that 1 is an x-intercept. Okay, Max?
Okay.
So 1 would be an x-intercept here. And we'll go through that in a bit. Okay, determine the value of k. So they gave us a hint, p of 1 equals 0, so let's sub in what we know. Okay, 0 equals p of 1. So 0 will equal the polynomial when all the x's are 1. So we have 8 times 1 cubed plus k times 1 squared minus 11 times 1 minus 3. So 0 will equal 8 plus k minus 11 minus 3. So we have minus 14 plus 8, so that's negative 6 plus k. Move that negative 6 over, and it becomes positive 6. And k equals 6. So knowing this little trick of the factor theorem and remainder theorem, it's going to save you a whole lot of a headache because you wouldn't want to have to do synthetic division or long division to solve for k. You have to know the remainder theorem. Alright, then we led into questions of how to factor polynomials. Okay, so first, this is a big hint, it's a shortcut. Rather than figuring out all the possible factors, what you could do is just plug this into your calculator and solve for those x-intercepts. So could someone please plug this into their y equals? So it's kind of a little cheat. Okay, let y1 equal the polynomial 2x cubed minus 9x squared plus 6x minus 1. Find x-intercepts. I actually don't like this. No, this will be a good question. I'm going to graph it with you guys so you can see it. Because there's something important to talk about. So 2x cubed minus 9x squared plus 6x minus 1. Okay, we're going to talk about the shape of polynomials in a moment, but what does this look like right here? What kind of shape? And that's called what in the polynomial unit? Tangent. You guys remember that? When it bounces off the x-axis, it's tangent. When it goes straight through, straight. When it has a change of concavity, what do we call that?
Concave.
Point of inflection. Okay, and that's all based on the multiplicities. Now, right now it looks like it's tangent, but because I've solved this already and algebraically solved it, I saw that it actually wasn't. So I'm going to zoom in a bit to make my window settings -2 to 2. But basically my piece of advice is don't be fooled by the initial look of the graph. I'm going to have to zoom in even more. But -0.5 and 0.5. Okay, on the x-axis, we didn't really need anything below 0. Let's put it to -1. Okay, do you guys see that now? It's gone above the x-axis. That means it's straight, straight, straight through the x-axis. This is a cheeky little question because it looks tangent originally, but it's not.
Are they going to do that on the diploma? Like, will they really do that? Will they plan us like that?
I don't know. Okay, so if you were asked to find all the zeros on a calculator, you would just have to go second trace 0 and then trace all those. Maybe just to save some work here, can you guys do the furthest left one, you guys do the middle one, and can you two do the far right one? Okay, let's solve for it. Okay.
Yeah. Oh, it froze.
Sorry?
3.73 is the last one. You guys were too slow. Oh, you did? My bad. Alright. So taking a look at these solutions here, they look a little messy, right? But this one, not so much, 0.5. That means x equals 1/2, right? If I were to write that as a factor, I would get 2x minus 1 as my factor. So 2x minus 1 is a factor. Okay, one question you might see is like, which of the following are factors of this polynomial? Okay, you could use the factor theorem, or you could solve using your calculator, and if you get 0.5, then
There's only one factor?
there's actually three solutions. There's 3 x-intercepts, but there's one factor that we can put in a simple binomial form. Okay, I'm going to show you how we're going to get these other two algebraically now. Okay, so my suggestion, guys, is instead of having to look at all the potential zeros, remember you look at factors of the constant, 1, -1, factors of the leading coefficient, 1, -1, 2, -2, and then you have to do all the testings using the factor theorem. You'd have to sub in 1, negative 1, what else would it be? 1 over 2 or negative 1 over 2. So you'd have to test 4 different values into the polynomial to figure out what we just simply did on our calculator really quickly. Okay, are you guys, am I making sense when I say testing it out? Does that, what I mean is, like, you would go p of 1 over 2, or p of negative 1 over 2, or p of 1, or p of negative 1. And you want to look for which one is going to give you a solution of 0, and the only one would be p of 1/2, which is a factor. Okay, so rather than testing those all out, this is why I'm saying just cheat. Put it in your calculator, find that first x-intercept. So, well, it's a little shortcut. Maybe I won't say cheat, I'll say shortcut. Shortcut. Alright, so I think we can all agree synthetic division is the easiest, so I'm going to put that factor on the side, 1/2. And I'm going to put the leading coefficients of my polynomial in the top row. Okay guys, just try and stay focused here. So we have 2x cubed, negative 9x squared, positive 6x, and negative 1. We're going to work our way through here. Bring down the 2. 2 times 1/2 is 1. Negative 9 plus 1 is negative 8. Negative 8 times 1/2 is negative 4. 6 minus 4 is 2. 2 times 1/2 is 1. Negative 1 plus 1 is 0. That's what we wanted, the remainder of 0. So just to summarize what we have so far, we have a polynomial that's equal to our divisor, x minus 1/2, times our quotient, which is 2x squared
Junior class change.
minus 8x plus 2.
Yeah, I thought it was 2x minus 1.
Where?
Like our
Here?
yeah.
It will be, and I'm going to show you how. Okay, so one thing you guys maybe forgot, could you just grab the door? There's a special type of synthetic division when we have binomials that have leading coefficients in front of the x. Okay, so right now, when I put it into a divisor, I have x minus 1/2, but what I can do next, what's a common factor in the quotient? 2. So I'm going to I'm going to factor out a 2 from the quotient. And what can I do with that 2 to make this look like 2x minus 1? And then multiply it in. So I now have 2x minus 1 times my quotient, x squared minus 4x plus 1. Boom. That's fully factored. And the reason why is because I can't factor x squared minus 4x plus 1. Are there two numbers that multiply to 1 and add to 4? No. Okay, so algebraically, what can I do to figure out? Okay, I already know this is x is 1/2. How can I figure out the x values from this if I can't factor? Say it.
Graph.
No, well, we already graphed it. Quadratic formula, good job. Okay, so let's just take our work over here. Quadratic formula. It is on your formula sheet. Hopefully you guys remember it too. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So let's sub in. We have negative negative 4 plus or minus negative 4 squared minus 4 times 1 times 1 over 2 times 1. So we have 4 plus or minus the square root of 16 minus 4 is 12 over 2. Am I going too fast? Okay, and do you guys remember how to simplify a radical? Grade 10? I need two numbers. One of them has to be a perfect square. 4 and 3. Okay, I'm running out of space here. Let's move over here. Okay, so we have 4 plus or minus. The square root of 4 is 2. Left with the square root of 3 over 2. Common factor in there? 2, 2, 2. So I gotta take out the 2's and I end up with 2 plus or minus the square root of 3. Someone, can you calculate 2 plus the square root of 3? What do we get as a decimal?
No.
Does it look like 3.73? Okay, and how about 2 minus the square root of 3?
0.26.
Is it 0.26 or 0.26?
0.267.
Okay.
949.
So 0.27. Alright, so that's how we can solve for our solutions on our calculator as well as algebraically.
So the one thing I don't get is how does it know to leave the as x minus 1/2 and not turn it into 2x minus 1 right off the bat?
Anytime your divisor on the side here is a half, like it's a fraction,
Right.
you always leave it as a fraction until you factor out of the quotient. And it will always work out that way. Okay, if you have a fraction on the side here, whatever you're left with in your quotient, you'll be able to put that back into the original divisor. Sorry, Max. Which step are you at?
The one where it's 4 plus or minus 2 square root of 3 over 2.
How did I get 2 root 3?
How do you get that to go to the 2 plus or minus square root of 3?
Okay, so 4 divided by 2 is?
2.
2 divided by 2 is? 1, and 2 divided by 2 is? 1. So I just took a 2 out of each of the terms. Alright. Moving on, the shapes of polynomials are very important. Alright, so things you might have to do, determine the multiplicities. So you have to think about, is the graph even or odd? You're going to look at your a value to decide that, your leading coefficient basically. Okay, you might have to find the y-intercept, and the degree will tell you which way the tails will point. So if the degree of a polynomial is even, do we have arms together or separate? Together. If we have a positive leading coefficient, arms up or arms down? Arms up. So we're not going to draw a polynomial, I'm just going to show where the arms go. So arms up, arms together, if we have an even positive polynomial. If we have an even polynomial, we know arms are together, but if it's negative, that means it's reflected over the x-axis, so arms will face down. Okay, if you want to put a little side note, arms together, feel free. Okay, if it's odd, arms will be opposite. Okay, if we have a positive leading coefficient, what we're creating, and this is my little trick, okay, if the arm is down on the left but up on the right, and you drew an imaginary line, we get a positive slope. Okay, which matches the positive leading coefficient. And if we have an odd polynomial, again, the arms are opposite, but a negative leading coefficient. If you were to draw an imaginary line to connect the tails, then you would get a negative slope. Cool? So just to see what multiplicities would look like on a graph, we're going to do that. Could you guys just change this to 1, 0 though? The last one there. Alright, so let's just add up our multiplicities. We have 1, 0 of multiplicity 1, 1, 0 of multiplicity 2, and 1, 0 of multiplicity 3. So the degree is always the sum of the multiplicities. So we have, that's 1 plus 2 plus 3, that equals 6. So we're looking at an even polynomial, and that means that arms are together, right? Okay, another thing that's shared with us is it's a negative leading coefficient. So arms are together and they're facing down. So if you wanted, you could just start your drawing off like that. 2 arms. It's not giving a specific x-intercept, so it can really be anything on this picture. Multiplicity of 1, how does that look as it crosses the x-axis? Straight, good. Okay, let's do that to start off with. Straight through. That's multiplicity 1. I just put M1 for multiplicity 1 here. Okay, if we have a multiplicity of 2, it is tangent. And if it's tangent, it gives that parabola shape, it bounces off the x-axis. So let's bounce M2. And then lastly, if we have multiplicity 3, what's it called, Chorney?
The concave.
So it has that
inflection.
look, point of inflection, yeah. So you're absolutely right, it changes the concavity. So that word that you were thinking about, it's good that you were, because you'll know the shape when you see it, right?
Yeah.
But you do need to know that it's called point of inflection as well. So make sure you grade that if you can. Okay, good stuff. So we drew our little polynomial and we satisfied all conditions. Yeah?
And multiplicity 1 is the only one that goes straight through, right?
Yeah.
And then evens it will bounce off and odds it will.
Yeah. So one thing I should point out too, sometimes you might have, say it's a tangent, you could have a multiplicity of 4 here. You could have a multiplicity of 6. Okay? Here, it's an odd multiplicity, point of inflection. It could be 3, 5, 7, 9, anything odd except for 1. Because when you have multiplicity 1, it goes straight through. Okay?
Wait, isn't it like it changed like the steepness depending on like what multiplicity? If it's like 9, if it has like a
Yes,
yeah,
absolutely. But the way it goes through the x-axis will be a point of inflection. Okay, if it was an 8, the steepness would be more steep.
Yeah.
Okay, but it would still touch the x-axis in a tangent form. It would bounce off. Okay. You remembered the steepness part. Good job. All right. Question you'll probably see something like this. Determine the factored form, finding the leading coefficient of a polynomial function. Okay, so determine first the factored form, place the stretch factor of a in front, and then given a point you can solve for what that unknown is equal to. So the question is, determine the equation on the factored form of a 4th degree polynomial function who passes through 1 and negative 12 and is tangent at 2, 0, negative 3, 0. So first you just want to set up your polynomial, y equals. You know there's going to be a leading coefficient. Okay, and then you have to figure out, well, what are the factors? It says that it's tangent. So if it's tangent to the x-axis at 2, 0, that means this binomial will be squared. And why is it squared? Actually, I might talk about that in a second. What would be the factor for the x-intercept 2, 0? X minus 2. Good. Okay, now we have another 0, and it says that it's tangent at negative 3, so x plus 3 squared. How did I know that it was multiplicity 2 and 2 and not like 4 or 8 or 6?
So that's degree 4.
Degree 4. Yeah, 4th degree. So when you add up the multiplicities, it has to equal the degree. Now how am I going to solve for a? I'm going to use that point, x, y, sub it into the equation, and solve for a. Okay, so next, sub in point, x, y, and then solve for a. Okay, so our y value is negative 12, a is still unknown, x is 1. So just sub in negative 12 and 1. Now simplify, negative 12 equals a. We have 1 minus 2 is negative 1 squared, gives me 1. And 1 plus 3 is 4. 4 squared is 16. So I have 16a equals negative 12. Divide by 16 and then distribute. Okay, so both have 4. So we have negative 3 over 4 is your a value. Is that the equation though? No, that's just the leading coefficient of our polynomial. So don't forget, you would have to write that out as an equation. Negative 3 over 4 times x minus 2 squared times x plus 3 squared. That's our polynomial.